Okay, so that is scanning and creating measurements in profile mode, but the sensor can do quite a bit more. We're going to go into the surface mode, and that's basically stacking up profiles into 3D maps. And we have a whole set of tools that can be used on these full 3D images from motion induced profiling. And so basically, if you stack up profiles with motion, you can build 3D maps and measure objects and create tools on those 3D surface maps. So to do that, I need to induce some form of motion, whether there are conveyors going by, or you have this on a linear slide or a robot arm. You scan over an object, and that's how you build a map. This rolling gantry that we have for demonstration purposes has wheels on it. It's got an encoder on here that I can activate and scan objects. So basically, what I'll do here first is I need to set the proper resolution for the encoder. I need to essentially calibrate that. And I just know that in this case, if I go into the manage screen here, this one in particular encoder and wheel is 31 microns per tick. That tells me when this encoder is ticking off motion, how far we've traveled, which is very important for us to recreate this. Now, can go into a basically a purely speed-based, so if you need the exact speed of your conveyor, you can put this in travel speed setting. You don't always have to use an encoder, but it certainly helps to use an encoder for a more robust installation. So once I've set that encoder, I can actually go in here, and instead of triggering on our time mode, we can now trigger in encoder mode. And so when I select an encoder trigger and I put an object underneath here, it will only trigger when I've moved a certain distance. So in this case, I select play, and every millimeter I get a new profile. So if I scan over my fingers here, you'll see with each millimeter I get a new profile. I can select whatever spacing I want. However, I have to be careful that I don't choose a spacing that doesn't allow me to scan at the rate that I want. So for instance, right now it tells me that the maximum frame rate is 200 profiles per second. That means if I choose a spacing of 1 millimeter, that I can't travel faster than 208 millimeters per second. Otherwise, I will trigger the sensor faster than the sensor can actually create these profiles. So sometimes we have to really be careful about how fast our process moves or what our spacing is. So what I'd like to do is scan this. This is a connector rod for an engine, and we'll scan this in 3D and take a look at it. But I want to scan it at a rate that's pretty quick, so that maybe if I'm moving down a conveyor at a certain rate of speed, that I need some kind of throughput. So what I'm going to do is show you how to increase speed. So right now, again, we're at a frame rate of 200 profiles per second. The way we increase speed is to actually reduce the active area. So if I select this active area, I may not need the entire depth of field because we have 80 millimeters, and this connector rod is only 20, 25 millimeters tall. So I can actually take this window that I have, basically the camera window, and I can reduce the height of it. Basically, we're not going to look at that area of the camera. We're only going to look in the region of interest of the imager. If I save that, you'll see my frame rate has now moved up to 640 profiles per second. In addition, if I really want to go even faster, I can actually go into the spacing area and I can subsample. This is a way to skip rows, skip columns, which actually allows me to reduce resolution for the purposes of gaining speed. So if I select 1/2 and 1/2, we're now at 2,000 profiles per second. So with this type of windowing and subsampling, we've been able to get sensors that can profile at rates of up to 5,000 profiles per second. In this case, we're just going to select the standard high resolution, but we'll keep that active area low so that we're at 640. So that'll allow me to travel quite fast. So to get a good scan, I'm going to actually drop this encoder resolution to 1/2 millimeter. And I'm now going to go, I'll reduce these windows, into surface mode. So prior to this, I was operating in the profile mode. I'm going to operate in the surface mode. And you'll see when I select that it actually creates a couple new windows. One is called surface generation. This allows me to generate surfaces in different ways. I'm going to show a fixed length surface generation. So what we'll do is we will basically stack up profiles over a certain length. In this case, we'll go, let's say we'll go 250 millimeters. So I'm just going to start scanning, and it's going to keep track of how far I've traveled. And when I've gone 250 millimeters, it's going to report this full data set to the screen. Let's hopefully I got enough stroke here. So there is the image. This is a height map. So this image is actually a bunch of profiles stacked together. Now we think we still have our filtering on. I'm actually going to take that off. Let's scan this guy again real quick. Okay, so there's a scanned image. Now we're looking at, again, we're looking at the height map. We can see we didn't quite catch all the object because I didn't have it positioned perfect. But each of these pixels on this image represent height. So the different colors range from about 0 up to a peak of about 22 or 23 millimeters. That's the peak height of this whole entire object. I can look at this a different way. I can look at it in a sort of a rotatable 3D mesh mode. So we look at that and we can see the surface here. Now if I'm scanning this object, I'm actually really not interested in what's going on with the table. So you can see this blue area is the area where the table is. But what I really would like to do is isolate the object from the table. So the way we do that is we go into a mode, instead of fixed length, we're going to use a continuous surface generation. And we're going to do what's called part detection. So part detection allows me to have say a conveyor or motion where it won't really record information until it detects a part that exists underneath the sensor. And the way we do that is through a height threshold. So right now the default setting here is 5 millimeters. So anytime we see something rise above 5 millimeters, we will know that we have something there, and we will continue to store that information until we fall below that threshold of 5 millimeters, and then we know the object has left our field of view. I will increase this max part length because this part's fairly long. And I will just scan over this object now with part detection. And the moment it leaves that field of view at the back end, we now have our image. And as you can see, the table is no longer involved here. Now we just have isolated the surface information of the object itself. So once we've created that, what do? Well, now we have a different tool set. So we have what's called the surface tool set. So there's a small hole here on the bottom of this connector arm, and I will select a surface hole tool. And we'll drag it over the area where the hole is. And now if I want to measure, say, the size of this hole and the position of this hole, I will select these various measurement features. And I will go in here and I need to kind of tell it a bit about this hole. What kind of hole is it looking for? I got to get it some sort of nominal radius. This hole looks like it's roughly 25 millimeters. We'll just put 13 millimeter radius, plus or minus 4. And there we go. We've got a hole measurement. It's doing a hole fit to that data. And we can look at that in a 3D. And you can see where it's projected that hole. And it's telling me that this hole is a radius of 11.2 millimeters and an XYZ position in a certain location. So similar to the profile tool set, we have a whole set of various tools that can be applied to the object. And if these arms are coming down the conveyor, I could measure each one and get its parameters. Okay, so we have quite a few other surface mode tools that I want to show you. I'll just take this rod out here and we'll use this target. It's got a few more features on it, some holes, some slots, some tilted angles, a stud on it. And so we'll just do a quick scan here of this guy. And I just want to get that tilted hole surface and stud in there. And we'll take that scan. And so with this scan, we will look at a few more features. So with this surface hole measurement, I will just create a new one. And this time we will look at this hole that's on the angle. So this would be really hard to measure if we had a 2D camera, because a hole on a tilted angle looks like an ellipse. So in this case, we're going to look at the radius of that hole. This guy's probably about 8 millimeters or so. Oh, I got it. There we go. So here is the measurement on that hole, and it's measuring 8.1. And you can see how it's fitting that hole even though it's on that tilted surface. So that's kind of the power of 3D versus 2D. And we have other tools here. We could get the plane angle of this surface. So if I go back to the plan view area and we put it over here, it fits a plane to that surface, and we can measure the X and Y angle of that plane. So our Y angle about that Y axis is going to be roughly 0, but the X angle is going to be very large. In this case, it's about 30 degrees, and in this case it's negative based on the polarity. So if I look at that, it fits a plane to whatever's in that feature box. So we could measure how surfaces are fitted together and whether they're on the right angles quite easily in the 3D mode. Another tool is this stud measurement. We've actually got specific tools for studs. So a lot of these tools were created for automotive applications, and we're building more and more tools over time, including tools that look at countersunk holes and slots and things like that. So in this case, I'm going to use surface stud, and we are going to drag it over that stud. And if we look at that in 3D, we are measuring the tip of the stud, the base of the stud. We can get its location in X, Y, Z for both the tip and the base, as well as the radius of the stud. So this is a much more sophisticated tool with a lot more algorithms inside to determine these various parameters. So that's a quick look at some of the tools in the surface mode.